Hey everyone, hope you're all doing well. Hopefully that quiz of yours wasn't so bad. We're on lesson 6 now, so we're continuing with the unit. We're still talking about functions. And today's lesson will be representing functions in multiple ways. So we'll see it as a word problem. We'll write it as an equation. We could express it in a table of values, and of course we could plot the points and see it on a graph. So if you could just write down this objective, that would be great. We will go over the do now together, and I'll do the development with you. And then for homework, you're going to be doing the 4 questions that are just like these questions in the video. So take really good notes so that you're ready for your test when it comes. So first, just a reminder about what is a function, since they're asking us if the following are functions. In order to be a function, every input can only have one output. And I had talked about in one of my videos that we can see functions graphically very nicely. If there's ever 2 points, one above each other, then it's not a function, because that means that there must be an input that has more than one output. So in A, yes, this is a function. Every input only has one output. Remember, your inputs are your x values. So an x value of 0 in this graph would give me an output of 0. An input of 1 gives me an output of 1. An input of 2 looks like maybe it's about 1.5. An input of 3, I don't know, about like 1 3/4. An input of 4 is definitely at 2, right? Sometimes we can't exactly see what the output is, but I could definitely see that every input only has one output. But in part B, no, this is not a function. There are some inputs that have more than one output. The input of 0 has an output of 0 and an output of 1. The input of and it has another output right here, an output of -2. So the input of 0 has 3 different outputs. The input of 1 also has 3 different outputs. I can't exactly read what they are, but there's 3 of them. Maybe the input someplace over here of about negative like 2 and change has 2 outputs. I know that some of the inputs only have one output, but in order for a whole graph to be considered a function, every input can only have one output. In C, I know that this is not a function from how the points are displayed, but some people get confused, so sometimes a mapping is even more helpful. Remember that inputs are your x values, so let's list the different input values that we see. I see a 0, I see a 1, I see a -1, I already wrote down 0, and I see a 2. So these are my inputs. The outputs, I see 2, -1, 4, -3, and +1. And then if I do the mapping, the arrows, 0 goes to 2, 1 goes to -1, -1 goes to 4, 0 goes to -3, and 2 goes to 1. So the problem right here is the input of 0. The input of 0 has more than one output, so this is not a function. In number 2A, it says using patterns. Can you complete the function table? And then in B, it asks us to create a rule for the function. So let's take a look at the pattern. So something we can't get tricked on is that the x's go 1, 2, 3, 4. It's skipping 5. And then there's 6, and skipping 7, 8, and 9, and then there's a 10. So you have to be real careful. Because some people would think that we do 4, 8, 12, 16, and then a lot of people would want to put 20 here. But 20 goes with the 5, so therefore 24 must go with the 6. 28 goes with the 7. 32 goes with the 8. 36 goes with the 9. So 40 goes with the 10. So if we were to do it using patterns, we have to think that way. But when you create a rule, you really want to know what can you do to the input to get to the output. Do you notice that you just multiply by 4? So the rule is y equals 4x. We could have done our slope, our change in y over change in x. From 4 to 8, it's going up by 4. From 1 to 2, it's going up by 1. So the first rate of change is 4 over 1. The next rate of change is also 4 over 1. The next one is 4 over 1. But if I were to get rid of this 5 right here, I just erased everything. If I were to look at this rate of change right here, from 16 to 24, it's going up by 8. But from 4 to 6, it's going up by 2. So guess what? It is the same rate of change. 4 over 1 is the same thing as 8 over 2. It's still a rate of change of 4. Right? And if I plug in these numbers into what I think my rule is, it works. I can pick the first x and y value and do like a check. Does 4 equal 4 times 1? Yeah, it does. And if you think maybe it only works for the first one and not any others, go pick one of the others. What if I pick this one? I would say that 16 should equal 4 times 4. And it does. So my equation, I'm really confident with it. It is correct. So now we're dealing with these multiple representations. The first one is in words. So at the north parking garage, it costs $5 to bring your car into the garage, plus $2 for every hour the car is parked. Remember, when you see these things like every hour or each hour, something like that, it's representing a rate of change. Remember, rate of change is a slope. So it's already giving me some hints about what the equation is. This $5 is a one-time fee. Whenever you pay for something once, it's your y-intercept, right? It's a one-time fee because you're going to just pay $5 to bring your car in. After that, you're paying the $2 for every hour. You're not constantly paying the $5. So the equation would be y equals 2x plus 5, where my x must be representing, so I'm doing some let statements here, my x must be representing the number of hours, where my y is representing the cost. So if I'm there for 0 hours, but unfortunately, I guess I drive in and drive back out, I'm actually going to pay $5. So this first line is kind of strange. If you're not going to stay and park your car, please don't drive in, because what a waste of $5 that is. But otherwise, it kind of makes sense. I'm going to drive in and pay $5, and I'm going to pay for 1 hour, so it should be $7. If we take a look at our equation, the y equals 2x plus 5, if I plug in a 1 for the x, I do get a 7. So you could kind of fill in this table using your common sense, or you can keep on plugging in each x value into the equation you wrote and find the answer. If I were to plug in a 2 in place of the x, 2 times 2 is 4, and then I add on the 5, this should be $9. Let's think about it logically. You drive in, you're going to pay $5, and then you're going to pay $2 for each hour you're there. If you're there for 2 hours, that's another $4. So yeah, it makes sense that it's 9. If you're there for 3 hours, that's 11. If you're there for 4 hours, it's 13. And if you're there for 5 hours, it's 15. So you can also see that since these hours were in a pattern, they didn't skip any numbers, which is important to recognize, because in the do now, they tried to trick you, right? They skipped some numbers. Since there weren't any numbers skipped in the x values, it means that our y values will follow a very nice pattern. It looks like it's going up 2 each time. Oh yeah, up 2 each time is a rate of change of 2. Like, it all just connects and makes sense. If we were to graph this, first of all, let's think about it. We are parking in a garage for a number of hours. Are you going to park for negative hours? No, so I don't need any negatives on the x-axis. I'm paying money. Are they going to give me money? No, so I don't have any negatives on the y-axis either. Lots of real-life situations have a set of axes that don't draw this. I wouldn't want to draw my set of axes in the middle of the graph because I'm not going to graph anything in these three quadrants. So if you know for a fact you're not graphing anything in three of the quadrants, why don't we just plot or make our axes in place so that I'm only seeing that one quadrant? So I want to put my y-axis here and my x-axis here. I don't know if you could tell I'm using a different program, so I have different colors. You'll have to let me know if this looks any better than the other stuff. But anyway, my hours go from 0 to 5. I could probably skip. It's nice to like spread things out. 1, 2, 3, 4. I can. Okay, so if you can spread out some things, it's nice to make your scale. So maybe it's easier to read. And you have to label everything. So I labeled the x-axis. I called it hours. Maybe I should put number of hours. And I put my numbers where I want each hour to represent. But now I have to get up to a charge of 15. I can't go by ones, can I? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, it only goes to 10. So I could probably go by twos. 2, 4, 6, 8, 10, 12, 14, 16. That would fit. I could probably go by threes, but I might be getting too squishy. I am going to go by twos. And sometimes when I'm writing on a computer, my things get a little squishy. So I'm actually going to go by twos, but only label every other. So that would be 4, 8, 12, and 16. Now you're allowed to do such things, of course, and this is the charge. And then we plot the corresponding points. For 0 hours, the silly person who drove in and didn't stay is paying $5. 1 hour, 7. All of these are in between, but that's all right. And you can see that my points do land in a nice straight line. And I used this program because I have a line tool on here that should help me draw a nice straight line. I could even move it if I need to, because it doesn't look like it started in the right spot. And the thing with this is that I'm not going to put an arrow over here on the y-axis, but I am going to put an arrow going out to the right. I can't put an arrow going this way. That doesn't make any sense because I can't go into negative hours. So make sure you're only plotting the things that make sense. And an arrow does make sense over here because I could probably park for more than 5 hours. Next. So they didn't give us a verbal description. They gave us somewhat of an equation. Kind of looks like an equation with some words. I'm going to change this cost into y and the number of texts into x. So it really does look like an equation. And they had to put those few words, I guess, so that we could actually make up a description. And the title is actually very important. It's about a monthly cell phone bill. And they're saying that the cost is 10 cents times the number of texts plus $50. So what could that really mean? If you're paying 10 cents for the number of texts, it means that you're paying 10 cents per text. Now, believe it or not, years ago when we first started texting, when I was a kid or Mrs. Lawton was a kid, there was no such thing as cell phones even. And then eventually cell phones came out, but cell phones were made for just calling. Eventually they started making some texts, like text features, but it wasn't like super popular, so they would charge you per text. And maybe it would be 10 cents per text. And you know, I was probably lucky if I sent out like 5 texts during the month because it wasn't a big thing when it first started. Now, oh my gosh, imagine your parents had to pay 10 cents per text that you sent. I think they'd like kill you. But anyway, if it's 10 cents for the number of texts, what the heck could this extra $50 be? Well, you usually have to pay a certain amount to maybe have a device or to have your phone on a plan, and then maybe you pay extra. I know everything nowadays is unlimited, unlimited data, unlimited text, unlimited calling. Crazy, right? So let's just think of the olden days. And this must mean that a phone company charges $50 for a plan, and an additional 10 cents per text that you send. I'm going to say plus. So notice how I wrote 10 cents. 10 with the cent sign, where over here it's 0.10. This means 10 cents. This means 10 cents. Never, ever, ever write 0.10 with a cent sign. That's not right. That's like a part of a penny. A cent sign stands for a penny. So 0.10 of a penny, that's like nothing. Anyway, let's fill in our table. So if we have the plan but we don't send any text, we're spending $50. If we have a plan and we send 100 texts, so you have to figure out what is 100 times 0.10, and you'd be allowed to use a calculator if you needed to. I would hope that you knew what 100 times 0.10 was. Do you? Yes, hopefully you were right. It's $10. So if you're paying $50 and another $10, this is $60. The next one is 20 texts times 0.10. Guess what that is? Yes, it's 20 plus 50. So that's 70. Notice the pattern over here. Are these going in a pattern? Yes, they are up by 100 each time. Therefore, this will follow this pattern, up by 10 each time. So that must be 80, 90, and 100. You could double check the last one if you want to. 500 times 0.10 is 50, and 50 plus 50 is 100. Again, are you going to have a negative number of texts? No. Negative number of dollars? No. So let's just make one first quadrant. Our x-axis stands for number of texts. Our y-axis stands for the charge or the cost. I need my x to get up to 500. I'm going to just every other one label 100. Do you know what that means your scale is going by? It's not by 100s since I'm skipping every other box. Yeah, my scale's going by 50s. Each box represents 50. And then on my y-axis, I have to get from 50 to 100. There is such a thing as putting like a break in the line. Or I could start at 0. So don't write any of this down. Let's just talk about this for a second. If I start at 0 and I don't put a break in the line and I have to get up to 100, I could probably go by tens. I could do 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And that fits. And that might be a nice thing to do. Just want to talk about what it means to put a break in the line, in case you don't know. So since the lowest thing I have to plot starts at $50, I could choose to put like this little zigzag here. And that means that I'm skipping a whole bunch of numbers. And then, since each of these are going up by 10, I feel like trying to spread this out. So I'm going to make this one be 50, 60, 70, 80, 90, and 100. I wouldn't have been allowed to do this without putting that zigzag there, because from the beginning to here it's going up by 50, which means that maybe each box represents 25. But did I really continue going up by 25 each time? No, I continued going up by 10. So this zigzag in the beginning says, hey, listen guys, I skipped a whole bunch of numbers, but now I want to go by tens. So I'm going to keep this, so you can copy this down. And now I'm going to plot and change my color. It's nice on this program, I have different colors. And again, not an arrow at the start, but I do want an arrow at the end, because I could text more than 500 texts, like you guys probably do. Next, tree growth versus years. So now I don't have a description. I don't have an equation. I do have a table. So I could see that there's years and that there's tree height. So at year 0, it must mean that I just planted the tree. So the starting height of the tree is 8. Remember, a starting height is a y-intercept. Something that gives it away that it's a y-intercept is that the x value is 0. Right? Whenever you have an x of 0, that y number is the y-intercept. So I could even like start my equation if I wanted to. I know I'm going to have like a plus 8 at the end. And then I should figure out how fast this tree is growing. It looks like it's increasing by 2 feet in 2 years. So if it's going up 2 feet in 2 years, how much is it going up each year? 2 over 2 is 1. It's growing at a rate of 1 foot per year. So 1x plus 8 would be my equation, where x represents the number of years and y represents the height in feet. So now I just said my story without actually writing it. I planted a tree. That I got from a nursery. The reason why I'm saying I got it from the nursery is because I didn't plant it from a seed, right? Because it started at 8 feet tall. Then it grew at a rate of 1 foot per year. And now we have to graph this. Again, 1 first quadrant. We're not having negative years. We'd need a time machine to go back in time. It's not shrinking, it's growing. So I have to get to 20 years. I'll go by 2's. I'm not going to put a break in the line. I want to get up to 28. I'm going to go by 4's. Yeah, I'm going to go by 4's. So notice each time I seem to be picking like a different scale. I really do plan ahead. I don't know if you notice, I like count my boxes, I figure out what's going to fit. I want to be able to spread it out nicely. Fours was good because I can see that the height of the trees are in multiples of 4 even. So first I'm going to plot 0, 8, 2, 10. So it's in between, but that's all right. 4, 12. 10, 18, 16, 24, and 28. So notice like this pattern did have like a break in it, but the rate of change stayed constant. So at first I said it was 2 over 2. If I were to look here, from 18 to 24, it's 6. And from 10 to 16, it's 6. So 6 over 6 is still 1. So the rate did remain constant, and that's why these points stayed in a straight line. And I do need an arrow over here because it's going to keep on growing. And then we just have one more problem, and then you can do your homework. Okay, so now they give me the graph. What's it look like? It looks like the y-intercept is 0, so I could come up here and put a plus 0. It's definitely a straight line, so it's in the form of y equals mx plus b. I just have to figure out what that m is. I'm going to use this and this point. Those 2 points are really nicely plotted. I'm going to look at the rise and the run. From 200 to 300, it went up 100. From 4 to 6, it went over 2. So the rate of change is equal to 100 over 2, which is 50. So I found my rate of change is 50. You can test it with like maybe these 2 points. Now I'm going up 200 and over 4. 200 over 4 is still 50. So this makes sense. Y equals 50, x plus 0, or I could just write it as y equals 50x. Let's look at the titles and the labels on the scale to see if we could make up a description for this. So it's about miles traveled versus the hours. So it seems like the more hours you're driving, the farther you go. That makes sense, right? If you're driving for a number of hours, the longer you're driving for, the farther you go. You're driving, obviously, at a constant rate because the line is straight. And we found out that rate of change to be 50. So on a trip that you're taking, I guess maybe during a time when you were on a highway, you were going at a constant rate of 50 miles per hour. And now I can fill in my table. Actually, I could just fill in my table from some of the points that I see in my graph. I saw a 0, 0. I saw a 4, 200. I see a 6, 300. I see 12, 600. I see 16, 800. They want another one. Who says I have to go in order, right? I could back down to hour 8. At hour 8, you went 400. So there we go. We're all done. I don't think that this was such a bad lesson. I hope you also thought the same thing. You only have 4 problems to do for homework, and I'll talk to you again soon. See ya. Bye.